So this is our question for the day. This is a class 2 central mass. In this specific system, you take monkeys as your system. When I consider monkeys as my system, what are the external forces here? The external forces here are one, gravitational force, two, tension force. For let me take MACM. This we know M1 A1 bar plus M2 A2 bar plus M3 A3 bar plus M4 A4 bar divided by total mass of the system, M1 plus M2 plus M3 plus M4. Let us take upward direction as plus J cap. M1 15 times A1 bar minus 1 J cap plus M2 25 times A2 bar minus 3 J cap plus M3 A3 0, because A3 is 0, even it is moving with constant velocity 0, divided by total mass of the system 15 plus 25 plus 20 plus 40, this is 60, this is 40, 100. So totally acceleration of center of mass is minus 6 by 10 J cap meter per second square. Minus J cap represents downwards. Right. Now, if I take the entire portion as my system, mg minus t is MACM. This, mg, area total is 100 into 10 minus t is MACM 100 times 0.6. So tension is 1000 minus 60, which is 940 newtons. Students, any doubt on this? Ask me now. If you have any doubt on this, ask me now. Bhavana, any doubt?
Monkey one is going upwards, sir.
Emma,
Monkey one is going upwards, sir.
where all the monkeys are going downwards only, no?
In the question I mentioned, sir,
No,
upwards.
no. You follow what is given in the question. That 1 minute. Okay. Right. I correct you said. What is your observation is right. This is 75. 75 minus 75 plus 15 is minus 60. My substitution is correct. Right. Any doubts? Right. Actually, the diagram need to be corrected. That's how it should be corrected. Right. The most important, same model. Only difference is arrangement difference. Everything is the same. Everything is the same. A triangular wedge of mass capital M is kept on a spring balance. Small block of mass m can move along the frictionless incline of the wedge. What is the reading of the balance when the block slides? Remember, spring balance responds to the pressing force or normal reaction force of the wedge. And I will call this as end wedge. Okay, but what are the different forces? One, the different forces acting on the system are, one is mg, and the other block is also there. The other is block's weight, mg. These are the external forces acting on the system. This is the system actually, and this makes an angle theta. So the weighing machine n wedge, right? Now you draw the free. No. See, please try to understand. Let me try to understand. The free body. So it won't move. This is this is fixed, but the block can move. For the block, the force is mg sine theta. So therefore, try to please understand. This will have an acceleration of g sine theta in this direction. Let us call A1 as block. A1 bar is, try to understand, this is x-axis, this is y-axis, and you know this is theta. So this is also theta. A1 bar is g sine theta cos theta I cap minus g sine square theta z cap. A2 bar wedge, no acceleration. The wedge have no acceleration. Now, if I ask you what is the acceleration, y component of the acceleration of the center of mass, you will simply say that m into 0 plus small m times minus g sine square theta, okay, divided by capital M plus small m. Therefore, the y component is see, I'm just giving you the y coordinate or y component of the acceleration of center of mass. Minus mg sine square theta by capital M plus small m. That's the deal. Right. Now you know ACMY. Now, as a whole, you take this as a system. Now, this is capital M plus small m. The system will experience capital M plus small m g weight, and the system will experience NW. As a result, ACMY. So, therefore, you can write this as capital M plus small m g minus NW is capital M plus small m times ACMY. Finally, n wedge is capital M plus small m g minus mg sine square theta. ఇక్కడ minus sign indicates direction. అంతేగాని మళ్ళీ మైనస్ ఆఫ్ మైనస్ ప్లస్ అవుదాం అనకండి అసైన్. Now the question is, have you followed? Bhavana,
Yes, sir.
Are what Varun?
Sir.
Any doubts?
Sir.
Clear?
Yes, sir.
Very important question. So you can expect questions of this type regularly, right? Don't you see both the questions are same model? Only difference is the starting point. Else steps are the same. Here you have T, here you have NW. That is the difference, right? Plank of mass M and length L is at rest on a frictionless floor. The top surface of the plank has friction. At one end of it, man of mass M is standing. I have already given theory for this. What is the theory for this? I've given the theory for this already. What is the theory? Displacement of the plank is minus small m by capital M plus small m times displacement of the man with respect to plank. Right. Now you tell me what are your observations. Now, regarding the first part of the question, color change, what we know is displacement of the man with respect to plank is plus L by 2. How do I know? Till the man reaches the center of the plank. So therefore, from this displacement of the plank is simply minus small m by capital M plus small m times L by 2. Negative sign indicates this is the positive side. And any direction leftwards, we will take it as negative. So the plank is moving leftwards by that much amount. Now we will move on to the next case. Till the man reaches the other end of the plank. In this case, displacement of the man with respect to plank is plus L. Yes or no? Any doubt? Now, displacement of the plank is minus small m by capital M plus small m times displacement of the man with respect to plank. And this is minus m by capital M plus small m times L. So, which clearly indicates leftwards by that much amount. Any doubt? Right. So, till this point, we are working on the basics. Now, I will work on some more theory again. What is the theory? Theory. Because we are giving theory at the initial pages itself. I hope you have started assignment, doing assignment. Right. Here, we will deal with center of mass. Okay. Center of mass, frame of reference. What is the center of mass frame of reference? If center of mass is the origin of a coordinate system, such a reference frame is called center of mass frame of reference. Now, in center of mass frame of reference, you can see that, see, I'll just give you a simple example. You take an arrangement like this. You have a block over here. You have another block over here. Right. Let this be A, let this be B. It is moving with speed u1 and this is moving with speed u2. Right. This is with respect to ground frame. What is the velocity of center of mass of this system? m1 u1 plus m2 u2 divided by m1 plus m2. That is the velocity of center of mass. Now imagine a frame, an observer moving with a velocity of vcm. With respect to him, velocity of 1 with respect to center of mass is u1 minus vcm, which is nothing but u1 minus m1 u1 plus m2 u2 divided by m1 plus m2. See, after careful algebraic work, you will get m2 by m1 plus m2 times u1 minus u2. Right. Right. Okay, fine. Similarly, velocity of 2 with respect to center of mass is u2 minus vcm. u2 minus same thing m1 u1 plus m2 u2 divided by m1 plus m2. And this is what you call m1 times m1 by m1 plus m2 times m1 u2, m2 u2, that will get cancelled and this is u2 minus u1. See, for a while you call u1 minus u2 as u relative. Right. You know, for this observer who is moving with the velocity of center of mass finds that A is moving with a velocity v1 cm and B is moving with a velocity v2 cm with respect to, this is all with respect to the frame attached to, with respect to the observer. This is the picture. In fact, this you will call as in C frame. Right. Now, what is the kinetic energy of this system? Kinetic energy in C frame is equal to half m1 v1 cm square plus half m2 v2 cm square. V2 cm square. This is nothing but half m1 v1 cm square is m2 by m1 plus m2 square u relative square plus half m2 times m1 by m1 plus m2 square times u relative square. By the way, you can write this further as m1 m2 by m1 plus m2 times u relative square. Any doubt? Ask me right now. Ask me right now. Bhavana, any doubt? Anika, any doubt? Varun, any doubt? Right. And for our convenience, this term we will call as the term m1 m2 by m1 plus m2 we will usually call as a mu reduced mass. Nothing is reduced there. But it is a mass term, we will write it like this. Remember, in ground frame, kinetic energy as recorded by an observer in ground frame is half m1 u1 square plus half m2 u2 square. But remember, in C frame, this is the kinetic energy. So how are they related? Half m1 u1 square plus half m2 u2 square is equal to half m1 plus m2 plus m1 u relative square plus something. This is KE in G frame, ground frame. And this is KE in C frame. And there is another factor. You know what is that? I'll change the color. And that is nothing but m1 plus m2 velocity of center of mass square. Okay, so that's the picture. So this is the conversion factor. Anytime if you wish to do a problem in C frame and you want to convert into ground frame, this is the conversion factor. Okay. So sometimes C frame is preferred to do problems. Such a problems I will discuss now. Please confirm, have you understood this? Remember, this is nothing but kinetic energy. Treating center of mass as a point mass, it's kinetic energy. That's all. Okay. Any doubt? This is the conversion factor. Anika, followed?
Yes, sir.
Right. అంటే ఇది డెరైవ్ చేయక్కర్లా ఎందుకంటే మీరు చేస్తే ఎల్హెచ్ఎస్ ఈక్వల్ టు ఆర్హెచ్ఎస్ సరిపోతుంది. ఐఎమ్ గోయింగ్ టు అప్లై దిస్ సొల్యూషన్ నౌ. Now they are asking something. Each of the blocks shown in the figure has mass 1 kg. The rear end blocks move with a speed of 2 meters per second towards the front. K is given. Maximum compression of the spring. Now, there is no external force. There is no external force here. Then you can conserve energy in C frame. In C frame, half mu u relative square is the kinetic energy. This is equal to half k x maximum square, or any time if it is x square compression, half mu at that time v relative square, which means at that time maybe they may have different velocities. What is the condition for x max? Condition for x max is, Anika, what is the condition for x max? Bhavana, what is the condition for x max? When do you say the spring is compressed at maximum? Boys, కరెక్ట్ గా చెప్పాలి.
Relative zero.
అరే మీరు చెప్పిన వాయిస్ నాకు వినిపించాలి, ఏదో మాట్లాడారు కానీ.
V relative zero, sir.
Yes, correct. Both the blocks move with same velocity. That is the time when spring is under maximum compression. Therefore, half k x maximum square is half mu v relative square, which means x max is under root mu by k times u relative. Bhaiya, what is reduced mass here? 1 into 1 by 1 plus 1, half kg. What is k? 15 Newton per meter. So this will become 1 by 100 times 2. And this will become 0.2 meter. Any doubts? Boys, any doubts on this?
No.
Right. Next question is also on the basis of the same. Right. Block A and B have 40 kg and 60 kg respectively. They are placed on a smooth surface. Okay. And right. And they are placed on a smooth surface, and the spring connected between them is stretched by 2 meters. Stretched by 2 meters. If they are released from rest, determine the speed of the blocks at the instant the spring becomes unstretched. Very simple. Same, whatever that I have done above, I need to do the same. Only thing is, A is 40 kg, B is 60 kg. 60 kg. Right. So what is happening over here? You have, no, 1 minute. First step, you do the problem in the C frame. Half kx square, initially they were rest, 0, is equal to no energy stored in the spring plus half mu v relative square, which means I am taking the case like this. I am taking the case initial you have compressed it. Final. Let us assume it has velocity v1 and let us assume this has velocity v2. We'll call this as A, we'll call this as B, we'll call this as A, we'll call this as B. At this stage, spring relaxed. Spring is compressed. Compressed. So therefore, the first observation is V relative square is K by mu times X square, or V relative is root K by mu X, which is nothing but K 180 and mu. By the way, what is mu relative? Mu relative, sorry. Mu, reduced mass. 40 into 60 divided by 100. 24 kg. Into X. Compressed. Stretched, sorry. String is stretched actually. 1 minute here. Is it string stretched or compressed? Then I'll do reverse simple. Hold on. No issues. Why should I draw a second diagram? Tell me. Now it is the situation where you said spring is initially stretched. Spring is relaxed. In this case, they will have velocities V1 and V2 like this. Story is still the same. And remember, this is final and this is initial. So I haven't done any mistake, just corrected my mistake. In fact, I read it as compressed. No, it's stretched actually. Okay, X 2 meters. 2 meters. Actually, 6 4s 24, 30. That's the deal. Root 30 is the answer, meter per second. Remember, V1 plus V2 is root 30 meter per second. Any doubt in this? Just ask me right now. Bhavana. You have two unknowns, but only one equation. Let me tell me how you can solve this question. Undoubtedly, you have two unknowns. V1 and V2 are two unknowns, but you have only one equation. How to solve? Varun. How to solve? Anyone in the class? Anika. Remember, there is no external force. There is no external force. Initially, center of mass at rest. So therefore, initially center of mass is rest because there is no velocity term at all. Finally, VCM must be 0. Now for this purpose, MAV1 minus MBV2 divided by MA plus MB is equal to 0 because there is no external force. No external force. When there is no external force, velocity of center of mass should remain constant. Initially 0. Finally also it should be 0. So therefore 40 times V1 is equal to 60 times V2. 2 times, 3 times. So we have V1 is 3 by 2 V2 and V1 plus V2 is root 30. So solving 1 and 2, we will get V1 and V2, right? Any doubts? Anika, any doubt? Varun, do you have any doubt? Boys, what concept that Tejaswini, any doubt?
No, sir.
What concepts I have used in this question?
No external.
One characteristics of Satra Pasala Vagati use చేశారు. Next, C frame of reference concept use చేశారు. Right. If you are learning as if like social studies, I cannot help you. That's the problem. Right. Now, these are very special models where we are expected that you are supposed to do this question. Forget about that question, just I am giving an idea. Block over block, you are extending. See, try to please understand. All these are identical blocks. Right. See, I need to place one over the other. But what is the condition? Let us say this is 1 and this is 2. The center of mass of the first block must at least be slightly to the left of the free edge of 2. Why? If this end is slightly to the right edge of 2, what happens is it will topple. So we should avoid toppling of that. So therefore, in this process, what we assume is that's the condition. Now, which means it is from this end at a distance of L by 2. Next. Suppose I have one more block, then how to handle it? Remember, now this as a whole you take a system, right? The combined center of mass of the system of 1 and 2 will be somewhere over here. This is called center of mass of 1 and 2. And this should pass through this edge. That is the maximum allowable. If it is to the left of 3, no issues. If it is slightly to the right of 3, right of the right end of 3, it will, the entire system will topple. By the way, this distance is L by 2 and this mass is the same. Therefore, obviously, this should be L by 4. This distance is L by 2. So, this distance is L by 4. Right. Aneka, till this point, any doubt?
No, sir.
Varun, any doubt?
No doubt, sir.
Right. Now I am using fourth block. I am using a fourth block now. Now tell me, where should this fourth block be placed? Now remember the center of mass. Now, forget about all. Place one single 2m mass here. And you again have m mass over here. This is a 2m mass. And this is a 2m mass separated by a distance L by 2. Then where lies the center of mass of this system? From here, if you take some R is small m by 3 small m times L by 2, which is nothing but L by 6. Bhaiya, from here, this system must be L by 6. I think now you got the clarity. L by 2, L by 4, L by 6. If there is a fifth one, it is L by 8 and so on. That's how it goes. Right? So the order is L by 2, L by 4, L by 6, L by 8 and so on. That's how the order need to be. This is how we maintain no issues. The entire system will stay in equilibrium. Varun, have you understood this?
Yes, sir.
Right. So obviously, if you are counting from ground, same thing will happen. This is L by 6. This is L by 6. This is L by 4. This is L by 2, likewise. So that is how you are supposed to count. This model is on the basis, same model is on the basis, whatever that you have, same basis, right? Toppling to avoid, right? M, right, to M. So here the center of mass has to pass through this end. Whereas at this point, what you will have is center of mass of 3, 2, 1. Likewise, you need to go the sequence. Any doubt on this, please ask me right now. Right. Now, we will do some more center of mass allocations. Right. For example, you are given a sector type arrangement like this. This is now this is some sector that makes an angle theta. I want to find the center of mass of this sector. For this purpose, you imagine an arc like this. This is some arc. I'll tell you about a term called sigma. Mass per unit area. Right. Now, y is, now if this is of radius r and thickness dr, y is located as r and dm is nothing but sigma r theta is the length of the arc and dr is the width of the arc. So y center of mass is 0 to capital R. Y dm by 0 to capital R dm. So, which is 0 to capital R sigma theta R square dr by 0 to R sigma theta R dr. Now, in this, sigma is constant, theta is constant. Ignore. So, what is that you are going to get here is R cube by 3 divided by R square by 2, which is nothing but 2 by 3 R. And that's the location of center of mass. Remember, when I am taking the location of center of mass, means, 1 minute, theta is missing. Let me just me that work. Y is Y is not R. Y is not R. What is Y? Y is R only, right? That is the location of R. I have done one mistake. I have done one mistake. No, this is not the way to derive. Hold on. Let me correct myself. Till this point, it is very clear. We need the location of center of mass. For an arc, where lies the center of mass? That also we need to know. No? For an arc, where lies the center of mass? That we need to identify. For this purpose, I'll draw something else here. This is disc type arrangement. For an arc like this, I have done one mistake in the location of center of mass of this arc. Of course, I assume that the total angle is theta. Fine. So you take one element over here, and this element which is here makes small angle d phi. Phi. And this angle is phi. Remember, what are the limits of phi? Phi tends from this point till this point. 90 minus theta by 2 to 90 plus theta by 2. Fine. Now I have some idea. Now what is the y of this coordinate? The y of this coordinate is simply r sine phi. Right. Till here I'm very clear. This time I'm very particular. I didn't do any mistake, and location is correct. So what is the mass of this element? Generally, this is a line. So we use a lambda. Lambda refers to mass per unit length. Lambda refers to mass per unit length. So dm is lambda or d phi, right? So all such elements will have YCM. Theta is equal to 90 minus 5 by 2 to 90 plus 5 by 2. And y Tm by, I know the mass. The mass is nothing but lambda r theta. With this, I'll try to do this part. So, yeah, what I'm getting is 90 minus 5 by 2, 90 plus 5 by 2. Yeah, what is our r sine r lambda r square sine phi d phi, but lambda r theta. Fortunately, constants, so you can cancel. And by the way, sine phi d phi is cos phi with negative sign. You can write this as cos 90 minus 5 by 2 minus cos 90 plus 5 by 2. There, 1 minute here. 90 minus theta by 2, theta by 2, theta by 2, theta by 2 by theta. There is some r also in the numerator. I don't have space here. I'll write all this content to the left hand side. So it is nothing but 90 minus theta by 2, 90 plus theta by 2, or sine phi d phi by theta. So 1 by theta time or r by theta times the integration part gives 2 times sine theta by 2, which means r sine theta by 2 divided by theta by 2. So that is the location of center of mass of an arc. Remember, an arc of radius r making an angle theta at the center. Now what about a disk? This is for an arc. This is for a sectorial disk. Sectorial disk. Yeah, please tell me now. So one such element, now sigma as usual. Sigma is mass per unit length. In this, sigma is mass per unit length. Right? One such element I am taking, y is, now you should use this relation, r sine theta by 2 by theta by 2. This is where I have done mistake. Now what is dm? Dm is r sigma r theta dr. Right. Now I am taking YCM. YCM is YDM by mass dm. So remember, this is 0 to capital R. In this sine theta by 2 pi theta is constant. Nothing to do with that. Sine theta by 2 by theta by 2 is a constant. And in the product process, your theta is also vanishing actually. Here, see, try to understand. Here, taking this product, theta gets cancelled. So therefore, 2 sigma sine theta by 2 is also a constant. Numerator में you will have r square dr. Denominator sigma theta r dr. Now sigma gets cancelled. Sigma gets cancelled. Sine theta by 2 by theta by 2 times. Now you speak to me here, r cube by 3 by r square by 2. So finally you will have 2 by 3r times sine theta by 2 by theta by 2. Varun, any doubts?
Okay.
Now I have done perfectly. No mistake anywhere here. No mistake, honestly. So this is for a sectorial disk and this is for an arc. Any doubts? Right. One more important point in this is, now similarly we will do moment of inertia of different items. One such item, all these things quite normal for us actually. All these things we will have like this. For example, you have hemispherical tension, for example. In case of hemispherical tension, what we will do is that there is hemispherical tension. In this, what we will do is we will take this as z-axis. Right. Now you take one such element. Right. You will have like this elemental ring. This is called elemental ring. Now this elemental ring, this makes an angle d theta. With the base units theta. Again, sigma is mass per unit area. So what is the mass of this small element? Sigma r d theta is the width. 2 pi 2 pi, what is this radius by the way? This radius is r cos theta. 2 pi r cos theta. Arey bhaiya, this is all area. That is it here. And the location of the center of mass of the ring is at the center of this ring only. So y is r sine theta. Basically, you need to understand these two terms only. Rest everything is the same. Hemispherical thin ring. I can slice it into rings. I took one such ring. One such ring means red is inner and blue is outer edge. The inner and outer edge at the center makes an angle d theta. And the entire radius vector makes an angle theta. And at the end of the day, you don't require to derive all these things. Finally, you need to remember this. But as my duty, I'm deriving this. So what is earlier I said as y axis, let us take. So YCM is integral y dm by integral dm. Okay. So by substitution, you will get this one as simply r, right? I'm not doing even that derivation. Remember, for a hemispherical thin shell, the center of mass is located at a distance of r by 2 from the center. That is a very important observation. Similarly, I will take one more thing. Hemispherical shell. Hemispherical shell. Right. For a hemispherical shell, now can you please guide me what I am going to do in case of a hemispherical shell? Anyone in the class? So I have derived it for thin shell. What am I going to do for hemispherical shell? Any idea?
Volume.
Pardon? I didn't get you.
Volume considerations.
Yes, we will take it as we will consider as thin shells, each made of thin shell, which means we will see now we are considering one thin shell here. You will do it like this: elemental thin shell. Of a radius smaller. Total radius is capital R. Radius is smaller. Now again, what is the mass of this piece? Rho stands for mass per unit volume. So dm is rho times 4 pi r square dr. That is the mass. Why? Here, shell of radius r, center of mass is at r by 2. Same relation. Y dm by integral dm 0 to capital R, 0 to capital R, which is YCM. By solving which, you will get this as 3R by 8. Now, at the end of the day, what you need to remember is for a hemispherical shell, hemisphere, the center of mass is at a distance of r by 8. For a thin shell, it is at a distance of r by 2, location of center of mass. Similarly, we will do it for cone, we will do it for the other structures, actually. Okay, one more important, triangle also. For a triangular plate, For triangular plate also, we will need to do. So you have, let this be y-axis and let this be x-axis. And you have a triangular plate like this. All right. That's the triangular plate. For this triangular plate, the dimensions are like this. It is B and height is A. For this triangular plate, what we will do is, you imagine some strip-like kind of arrangement like this. This is dx width, and by the way, this is at a distance x. Right. Now, see, please try to understand. This is b minus x. You know the center of mass of this strip locations are x, b minus x by 2 tan theta. This is theta. So therefore, what is the first strip? Y, center of mass coordinate is, this is x comma y for example. Y is nothing but b minus x by 2 tan theta. No, I see, plate anangane sigma stands for mass per unit area. By this time you have understood. If it is a length piece, lambda. Area piece, sigma. Volume piece, rho. So therefore, what is YCM? YCM is nothing but YDM by integral dm. By the way, what is a dm? Dm is nothing but sigma times y b minus x tan theta times dx. Yeah, area loss. So by substituting all the terms here, you will finally get this term as just taking care of all these things. You will get something like this. This product together, sigma tan square theta by 2 b minus x square dx 0 to b by dm sigma tan theta times b minus x dx 0 to b. So by deriving which, you will get b by 3 for this. YCM, you will get b by, very simple. In the place of b minus h, you take anything. Sigma also you can do. By the way, tan theta is a by b. So finally, this is a by 2b times, you'll get y 2 by 3, I think this one you'll get as 2 by 3, 2 by 3 times B. So after cancellation, you will get A by 3. YCM becomes A by 3. XCM is B by 3. Same. See, how the way I have done YCM, you can do it for X also. So therefore, finally, XCM comma YCM is B by 3 comma A by 3. This you need to remember. But right angle triangle, మిగతా triangles కి కేసుని బట్టి తీసుకుంటాం. But triangular plate, at least you need to remember this. Any doubts, please ask me. So I have reduced the integration steps, that's all. Finally, you need to remember the concept. Any doubts, please ask. Till this point of time, if you have any doubts, please ask me. Anika, any doubts?
No doubt, sir.
Akka,
Yes, sir.
right. Varun,
No doubt.
Tejaswini.
No doubt, sir.
So final గా మీరు గుర్తుపెట్టుకోవాల్సింది షెల్ R/2, hemispherical shell 3R/8, triangular plate B by 3 comma A by 3, and two more things are also there. Two more things also there. I don't have space to incorporate, but I'll try. I'll incorporate here one day. Right. Two more situations also there. They are not different things at all totally. See, basically here I am discussing about cone and solid cone, and location of center of mass of solid cone and hollow cone. Okay, same thing like disk concept you will derive. In case of solid cone, right. 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 In case of solid cone, radius R, height H. What you will take? You will assume this as y is equal to 0 basically. You will assume the semi-vertex angle as a theta, and you will take a disk as the criteria here. You will take one such a disk. This is one such disk. And all such disks, you will take the center of mass location. Like for example, what is the radius of this disk? R. So R is y tan theta. Radius is y tan theta. So what is rho stands for mass per unit volume. So what is the location of center of mass? YCM is integral 0 to h, because you will have 0 to h ydm by hdm. So what is dm here? Dm is nothing but pi r square dy, and that's all. Now you substitute, trust me, after substitution of all these things. Why? Because even though I did, finally you will just remember the, the base content only. So you will get 3h by 4. Or from the base, the location of the center of mass is h by 4. Any doubts? I am not cheating, I'm just giving you the basic substitution here. For a solid cone from the apex, it is 3h by 4. From the base, it is h by 4. For a hollow cone, for a hollow cone, of height h, radius r, from the base, it is at a height of h by 3. These things you need to remember. So most of the structures I have given. Basically, try to please understand most of the structures. What I mean is different structures I have given the location of the center of mass. Suppose apart from this, if you had any other structure, yeah, you use the technique which I have given right now and thereby derive it. But basically, the methodology which I have given you, which I have suggested, that's fine. I don't think you will get anything more than this. Right. Now we'll straight away do some more problems on the same. Right. So in fact, I have started with this as the criteria. Right. Now, mass per unit area of the disk in first quadrant is sigma. In the second quadrant is 4 sigma. In the third quadrant is 5 sigma. And in the fourth quadrant is 8 sigma. The coordinates of center of mass of the system are. Just now we have derived this. Just now means some time back at today's class only. So this is 2 by 3 r sine theta by 2 theta by 2. That's right? Which is basically it is some function of r. That's for sure. Function of r. So rest all is a constant. What I suggest is it's purely depending upon the radius. So therefore, right, here lies the center of mass of one such system. Here lies the center of mass of another system. Here lies the another center of mass of another system. Here lies the center of mass of another system. 4 different locations, but all depends on R only. Let us say that the dependency is some K times R. Agreed? Rare 2 by 3 R, sin theta by, everything is common, depends purely on radius. Agreed? Bhavana, yes or no?
Your voice is breaking, sir.
My voice is breaking. Now how it is?
Now it's okay, sir.
Right. It all depends on radius only. So I'll say that it is some constant, some K times R. It is that distance from this point is some K times R. R is K times R. Now, therefore, what is, now I'll write terms like this. M1 is each sector area we will take as A units. Sigma A. X1 is K by root 2 R. Y1 is K by root 2 R. First part is done. Second part, M2 is 4 sigma A. X1 is minus K by root 2 R. X2, sorry, Y2 is plus K by root 2 R. Right. So done. Similarly, M3 is, M3 means this 5 sigma A, and X3 is minus K by root 2 R, and Y3 is minus K by root 2 R. M4, M4 is 8 sigma A, X4 is X4 is K by root 2 R, and Y4 is K by root 2 minus K by root 2 R. Almost all the coordinates available for me. One shot I can answer now. Coordinates of center of mass of the system. So what is XCM? XCM is, you know this formula, M1x1 plus M2x2 plus M3x3 plus M4x4 divided by M1 plus M2 plus M3 plus M4. Trust me, numerator and denominator, A gets cancelled. Numerator, entire thing, K by root 2 is a constant. Okay, that we will find later on. Hold on. Now we will find later on. Now, mass sigma A, 4 sigma A, 5 sigma A, 10 sigma A, 18 sigma, 18 is in the numerator, denominator. Numerator, product, K by root 2, I'll take K by root 2, or I'll take common out.
Sir, your voice is breaking again, sir.
Internet issues.
Sir,
1 minute. Just give me time.
sir, we are not able to hear you.
Now, is the voice clear? Now am I audible? Is my voice clear now?
Okay, sir.
And is the screen sharing available?
No,
Is the screen available for you now?
no.
Right. Is my voice audible? Right. Now in this, if you take numerator and denominator sigma A terms will come common. So I'll eliminate all. Finally, 1, 4, 5, 8. So totally this is 18 in the denominator. Even KR by root 2 is also common everywhere. Now, 1 minute. Now I'll take the products 1 into 1. 4 times minus 1, minus 4. 5 times minus 1, minus 5. 8 times 1. Fortunately, the numerator cancelled. 0 by 18.
Sir.
0. Yes. Hey, just boys, tell me, is my voice audible?
Yes, sir.
Audible or not? Just please confirm.
Yes, sir. Yes, sir.
Right, right. With this, you can say that XCM is 0. Similarly, you find out YCM. YCM also you will substitute M1Y1 plus M2Y2 plus M3Y3 plus M4Y4 divided by M1.
Sir, you are not sharing.
I'm sharing here actually. If it is not clear, I'll stop class. You better work on this. And now, right. KR by root 2 times. Denominator 18 is okay. Now numerator, here 1 into 1 plus 4 into 1 plus 5 into minus 1 plus 8 into minus 1. What is this totally? 4 plus 5, 5 minus 5, 8 by 18. So minus 8 by 8 times R by root 2 times K. So that K term already we know what is that? 2R by 3 times sin theta by 2. Sin theta by 2 by theta by 2. 2R by 3 times. By this is 90 sin 45. 1 by root 2 by 45. 5 by 4. Here substitute here. You will get the answer as A. So the concept is how to identify locations of individual center of masses. That's all. Here I'm getting, I don't know what is the reason, getting repeated disturbances. Maybe from my end only, net is not clear. So I'll just stop the class over here. You keep working on the assignment questions and